You've probably played around with something like ChatGPT or Gemini and wondered, what's actually going on in there? I mean, it feels a lot like magic, right? Well, today we're going to pull back that curtain. We're going to demystify the core technology that is literally changing our world, the large language model.
And really, it all boils down to this one central question. How can a machine, just a bunch of circuits and code, seem to get language? How does it understand all the nuance, the context, the creativity of how we talk? That's the huge challenge these models were designed to tackle. And the answer is, well, surprisingly simple when you get right down to it. At its heart, an LLM is basically a giant prediction engine. Think of it like a super-powered autocomplete. It's a special kind of neural network that's been trained on a truly insane amount of text. And its one and only job is to get really, really good at guessing what word comes next in a sentence.
Okay, so here's how we're going to break this down. First, we'll look at the massive breakthrough that kicked all of this off. Then we'll dive into how these transformer models, you'll be hearing that word a lot, actually process language. After that, we'll see how they're trained, and finally, we'll get into some of the really important ethical questions this stuff raises. So let's start at the beginning. How did we even get here? I mean, this technology didn't just pop up out of nowhere. It's actually built on decades of research. But there was one key moment, one single breakthrough that really lit the fuse for the AI explosion we're all living through right now. Believe it or not, the basic ideas for neural networks go all the way back to the 1950s. Fast forward to the 2010s, and we had models called recurrent neural networks, or RNNs. They were okay, they showed some promise, but they had this huge problem. They had a terrible memory. They'd forget the beginning of a long sentence by the time they got to the end. But then, 2017 happened. A landmark paper with an amazing title, Attention is All You Need, came out and introduced something totally new, the transformer architecture. This wasn't just an improvement, it was a complete game changer. It's the direct ancestor of the models we all know today, like GPT and BERT. And if you want to see the impact, just look at this chart. It's wild. The number of parameters, you can just think of those as the dials and knobs the AI can tweak to learn stuff, it just went completely vertical after 2017. We're talking about a jump from millions to hundreds of billions in just a couple of years. It's this mind-boggling scale that unlocked the incredible power we see today. Okay, so what is the secret sauce here? What makes this transformer architecture so special? How does it actually take our words and turn them into something a computer can work with? Let's pop the hood and take a look. It really comes down to three main steps. First, you have to break the text into smaller pieces. Second, you have to turn those pieces into numbers. And third, and this is the really clever part, you have to figure out how all those pieces relate to one another. All right, step one, tokenization. It sounds complicated, but it's not. It's basically just breaking a sentence down into its building blocks, or tokens. Sometimes a token is a full word, like cat, but a more complex word, like tokenizer, might get broken down into token and izer. This is super useful because it helps the model deal with grammar and even figure out words it's never officially seen before. Okay, next up is embedding. Remember, computers don't speak English. They speak math. They need numbers. So the embedding process takes each of those tokens we just made and converts it into a long string of numbers. It's called a vector. And this is where it gets really cool. This vector actually captures the meaning of the token. So words with similar meanings like king and queen or dog and puppy will have very similar sets of numbers. This is the first step in how an AI starts to actually understand what words mean. And now we get to the real breakthrough. The idea that changed everything. Self-attention. Let me give you an example. Think about the sentence, the animal didn't cross the street because it was too tired. Now, you and I know that it refers to the animal, not the street. But how does a computer know that? Well, that's self-attention. It's the mechanism that lets the model, when it's looking at the word it, scan the rest of the sentence for clues. It figures out that it has a really strong connection to animal and almost no connection to street. This ability to see the relationships between words, even far apart ones, is what allows these models to understand context and do amazing things like summarize a whole book. And if you could look deep inside the model's architecture, this is what you'd find: the attention mechanism. This is the engine room. This is the part that does the heavy lifting, constantly weighing the importance of every single word against every other word to build that rich understanding of context. Okay, so we've got the architecture down. But an empty network isn't useful, right? So how does it actually learn? How does it go from a blank slate to a tool that can write poetry? Well, it basically goes to school.
And this schooling happens in two main stages. First, you have pre-training. Think of this as the AI's general education. It's basically turned loose on a massive digital library. We're talking huge chunks of the internet, and its job is just to read everything and learn the general patterns of language, grammar, facts, how people talk. Then comes fine-tuning. This is like specializing. You take that generally educated model and train it on a much smaller, specific set of data to get it really good at one particular thing, like being a helpful chatbot or translating languages.
And when I say massive, I'm not kidding. A lot of this pre-training data comes from data sets like the Common Crawl. And that is exactly what it sounds like. A gigantic, publicly available archive of billions and billions of web pages. So it's learning from literally everything. News sites, blogs, forums, Wikipedia, you name it.
And this chart gives you an even better idea of the variety. This is for a dataset called the Pile. And you can see it's not just random websites. Look at this. There are huge slices for academic papers, a big chunk for books, and even all this source code from GitHub. It's really trying to soak up a massive, diverse collection of everything humanity has ever written down.
But there's a huge catch to learning from this giant, unfiltered pile of human text. And this brings us to what might be the most important part of this whole conversation, the ethical tightrope we're walking.
So here's the fundamental problem. An LLM is a mirror. It reflects the data it's trained on, and that means it doesn't just learn all the amazing, wonderful things humanity has written. It also learns all the terrible stuff, the good, the bad, and the ugly. It soaks up every bias, every stereotype, and every piece of misinformation. Because at the end of the day, it has no moral compass. It doesn't know right from wrong. And that opens up a whole minefield of ethical risks. These models can easily repeat and even amplify harmful societal stereotypes. And when an AI says something damaging or just plain wrong, who's to blame? The person who used it? The company that built it? It gets really tricky. And that's not even mentioning the massive questions around jobs being automated, or how an English-dominated internet could steamroll other cultures, or how this amazing tech might just make the gap between rich and poor even wider.
So if there's one thing to take away from all this, it's this. For all their incredible complexity, these models are ultimately a reflection of us. Their greatest strengths and their most dangerous flaws are a direct mirror of the data we feed them. They're incredibly powerful tools for sure, but they are not and cannot be objective.
And that leaves us with maybe the biggest question of our time. As this technology becomes more and more a part of our daily lives, as it gets woven into the very fabric of our society, who gets to write the rules? Who decides what's fair, what's safe, and what values we bake into this new AI-powered world?